Day 9, we're going to take a look at decreasing geometric sequences, and then also look at some review. Prairie dogs are small mammals that are members of the squirrel family. The average size is about 14 to 17 inches, and they live in underground colonies called prairie dog towns. They are native to the Great Plains region of the United States. The prairie dog population is estimated to have declined 95% over the past 200 years, so prairie dog reserves have been established in some areas. Prairie dog reserves are places where prairie dogs can live in their natural habitat without being disturbed by hunting or other human activities. One such prairie dog reserve was established on 120 acres of land in 2015. As the surrounding land has become more valuable for humans, the size of the reserve has been reduced over time. Here's the following data that's been collected about the size of the reserve. So we can see every year that goes by, the size is decreasing. So goal is, can you figure out if this is arithmetic or geometric? Are you subtracting or dividing? So one way to figure it out is subtract one number from the one before it and keep doing that and see if you get a common difference. Or if that doesn't work, take one number and divide by the one before and see if you have a common ratio. So here, I tried subtracting first, and I found that this is going down every time by 7.5. So we're subtracting 7.5 every time. So write the explicit and recursive equation. All right, so first the explicit. This is linear. Actually, I'm going to start with the recursive equation. So the recursive equation, we have the first term, or the first year, there's 120 acres. To find the amount of land after each year, take the 1 year before it and subtract 7.5. So here's the recursive equation. Two parts, starting value and how you get from one previous term to the next term. The explicit equation, if it's arithmetic, is linear. So we're thinking slope and y-intercept. So to find the amount of land after any year, we need a starting value, so that would be at year 0. We'd have to go backwards and add 7.5. So if there was a year 0, we'd start with 127.5 acres of land, and each year that's going down 7.5 acres. So there's your slope next to the end, minus 7.5 each year. So since we're subtracting the same amount or adding a negative every year, this is arithmetic. And then number 3, the sale of the land at the reserve was stopped when the reserve was 76.5 acres because biologists who study prairie dogs found the population was declining at the alarming rate of 20% per year. They determined that the decline was due to several factors, including the reduction of habitat from selling off the reserve land. When the reserve began, the prairie dog population was 600 individuals. Can you model the prairie dog population over time in years starting with the beginning population? All right, so one thing that we will review more is that when you have a percentage, you change it to a decimal. So if it's declining at 20%, we would change it to a decimal by dividing by 100, so that's 0.2. But if it's declining at 20%, what percent is still alive? And so you have to take 100%, or 1 minus 0.2, and here's our common ratio is 0.8. So 80% of the year before is the present population for any given year. So if we make a table, let's say we do year and then the population. On year, let's see, I'll just call this year 1. There's 600. After a year, you would multiply by 0.8, and so that's 480 prairie dogs there the next year, and you would keep going. So let's write the explicit and recursive. I'll do recursive first in blue. So year 1, 600. To find any year, you take the year before it and multiply by 0.8. 80% of the population from the year before exists. If we go to explicit, this is geometric. And when it's geometric, you have first term times your ratio. And since we're starting at year 1, it'll be the n minus 1 power. If it was year 0, it'd be to the n power. What type of sequence is represented? Geometric, because we're multiplying by 0.8. There's a common ratio of 0.8. Okay, so that was kind of the new part, is looking at the context of this, taking a percentage and changing it to a decimal. Also, if it's decreasing, subtracting from 1. So let's do a little bit of review. So all of the rest is review things you've seen before and should know how to do, but we'll go over it if you don't. Determine whether the given information represents arithmetic or geometric, and then write the rule. So this one looks like it's going down by 6 every time. So it's going down by 6. 24 minus 6 is 18. that would be arithmetic. The recursive rule, first term is 30. To find any term, take the 1 before it and minus 6. Explicit, think linear. So here we're going to start, let's go backwards. So we would start at 36, and we're subtracting 6 every time. This one looks like we're dividing by 2, so that would be geometric. The recursive, start at 20. So first term is 20. To find any number, take the 1 before it and divide by 2 or multiply by 1/2. Explicit equation, we start at 20, which is the first number in the list. Multiply by your common ratio to the n minus 1 power. Ooh, number of cells. Okay, this one's adding 3, but then not adding 3, so it must be geometric. So you take any number and divide by the 1 before. Check it with 2 of them. So 8 divided by 5. Oopsies. 1.6, let's try it again. 12.8 divided by 8. Yeah, 1.6. So this is geometric, the common ratio 1.6. So the first term is 5. To find any number, you take the 1 before it and multiply by 1.6. The explicit, we need first term times 1.6 to the n minus 1 power, since we started the first term. Okay, review. Maria invested $6,000. If you get 10% a year, first step, change it to a decimal. And then if it's increasing, add 1. If it's decreasing, subtract from 1. So this is geometric. The common ratio is 1.1. The recursive rule is, okay, so this is an investment. This is the 0 term. And then to find the amount any year, you take the 1 before it and multiply by 1.1. The explicit would be 6,000, increase of 1.1 per year. And you wouldn't need to do the n minus 1 here because you're starting at year 0 instead of year 1. So to practice this, we're looking at day 9 in Delta Math. It's very similar to day 8. Remember that if you want to type in like to the n power, n minus 1, hit shift 6 in Delta Math, and then you'll get that exponent. If you finish any missing work after I've graded it, then you want to email me and let me know. And that is it.